Welcome to O'Reilly Maths. This is the 2022 Leaving Cert Ordinary Level Paper 1 and we're looking at question number 1. The complex number Z1 is shown on the Argand diagram below. There's the complex number Z1. Part A says, using the Argand diagram, write down the values of Z1 and Z1 hat. Okay, this hat means the conjugate of Z1. So Z1 you can see is minus 2 minus 3i. And the conjugate of Z1, remember the conjugate will be the same number except the sign of the imaginary part is changed. So it'll be minus 2 plus 3i. Part 2 then says plot and label Z, the conjugate of Z1 or Z1 hat on the Argand diagram. So that would be minus 2 plus 3i. So it's going to be here. So that's the plot, and don't forget to label. That's Z1 hat. Okay. And you can see there that Z1 hat is a mirror image of Z1 through the through the real axis. Okay, it's a reflection through the real axis. Okay, so that's part A. It then tells us Z2 and Z3 are two other complex numbers. Z2 is minus 5 plus 3i, and Z3 is 4 minus 2i, where I squared is equal to negative 1. Part B asks us to plot and label Z2 and Z3 on the Argand diagram on the previous page. So Z2 is minus 5 plus 3i. So we go minus 5 plus 3i. This is Z2. And Z3 is 4 minus 2i. Over to plus 4 in the real, minus 2i. Z3. So we've plotted and labeled. And part C then says, write Z2 minus Z3 in the form A plus BI, where A and B are real, elements of the real set. I squared is equal to negative 1. And hence find the modulus of Z2 minus Z3. These straight brackets here mean the modulus of Z2 minus Z3. So once we work out Z2 minus Z3, we then find the modulus of that. And the modulus, remember, is the distance from the origin to the complex number, to the plot of the complex number. Okay, so let's find Z2 minus Z3 first. So Z2 is minus 5 plus 3i minus Z3 minus, now when you're subtracting complex numbers, make sure you protect the number you're subtracting with a bracket. So Z3 is 4 minus 2i. Okay, now the reason we protect there is because this minus effectively multiplies in here. Minus bracket 4 is minus 4. You know, when we rewrite this here, it becomes minus 5 plus 3i. Minus by 4 is minus 4. And minus by minus 2i is plus 2i. Minus multiplied by minus, giving us positive. And now we can just tidy that up. You can see there we have our minus 5 and our minus 4. So we can combine them to get minus 9. And then we have our 3i plus 2i. And that'll give us a plus 5i. Okay, so that's Z2 minus Z3, and hence find the modulus of Z2 minus Z3. So that would be the modulus of minus 9 plus 5i. Remember the general rule for the modulus of A plus BI is equal to the square root of a squared plus b squared. So what this is doing effectively is it's performing Pythagoras on the triangle that's formed between the plot of the point and the origin. So all we do here is you need to realize, I suppose, that our a value is going to be -9 and our b value is +5. It's just the number in front of the I, not the I. Just doesn't include the I. So for us it's going to be the square root of -9 squared, that's our a squared, plus 5 squared. So that's equal to the square root of 81 plus 25, which is 106, square root of 106. And then you should check, does that simplify? Does the square root of 106 simplify? And it doesn't, so that's the answer. Okay, finally, part D asks us, investigate if Z3 is equal to 4 minus 2i is a solution of this equation, of the equation z squared plus 2iz minus 7i. So is this a solution? Well, if you want to find out if that's a solution, all you need to do is plug this in for z, anywhere you see z, plug it in. Okay, and if you work this out and it becomes 0, then it is a solution. So our equation will become 4 minus 2i squared plus 2i times z, which is 4 minus 2i, minus 7i equal to 0. So we're going to see, does this give us 0? So again, just to be clear, we've put that in there instead of z in the equation, substituted it in. So just watch out for these. When you're squaring a bracket, it's the bracket multiplied by itself. This comes up in a lot of other areas of algebra as well. Now we can multiply this in. 2i times 4 is plus 8i. And 2i multiplied by minus 2i, that's going to be minus 4i squared. We still have our minus 7i here. We're still hoping it gives us 0. So now we multiply out the brackets. 4 times 4, 16. 4 times 2i, sorry, 4 times minus 2i is minus 8i. Minus 2i by 4 is minus 8i. And minus 2i multiplied by minus 2i, be careful with that one, is plus 4i squared. Plus 8i minus 4i squared. I'm just rewriting all that stuff on top. Okay, so let's see. Well, we have plus 4i squared minus 4i squared, so they cancel each other out to give 0. We've got minus 8i plus 8i. They cancel each other out. Then we've got 16 here, minus 8i minus 7i. So that would give us 16. Minus 8i minus 7i is minus 15i, which is not equal to 0. So the conclusion would be Z3 is not a solution. If it was a solution, it would be give us 0 on the left. And that's the end of the question.